All right, so here's a more simple example. We're just trying to find the derivative of this function. And so we want to find f prime of x. And so we just find the derivative. We're using the sum rule of derivatives here, and then we also have a product rule here. So as far as the sum goes, we can just take the derivative of this, right, and then add it to the derivative of this. So the derivative of cosecant x is pretty straightforward. It's just negative cosecant cotangent. All right, and that's something that you can find just by looking at your trig cheat sheet, and or you can use your textbook, right? Not on a test, but on the assignment. All right, and so that's the derivative of this part. Now we need to find the derivative of this part, right? And that's where we have a little product rule going on. So we have a f function and a g function. So what is the derivative of f? Good, it would be 1. And what's the derivative of g? Yeah, the derivative of tangent would be secant squared. Good, so we have, we'll have f prime, so 1 times regular g plus g prime times regular f, right? And you could actually, once again, just go straight to the answer. So that would be just putting this in the front, just simplifying this. So, and then 1 times anything is itself. So our final answer could be negative cosecant cotangent plus tangent plus x secant squared. All right, and you can put those in any order, right? If you wanted to, put the positives first, then put the minus at the end, that's fine too. If you want to move that to the back. But yeah, that's basically what we do. So just using those formulas, looking them up, it's not something that I'll probably ask you to memorize all these, but it is something that hopefully will become second nature. Hopefully something you'll memorize just through repetition and practice. But and I think a lot of these are good to memorize. Definitely sine and cosine, and I would say all 6 trig functions are good to know. All right, so try this one out and see what you get. So here we have a difference, and so this one's a little easier than the other one because there's no product rule in here. It's just constant multiple, and so it should be pretty straightforward. Just one step, and you should be able to get the answer. All right, and if you got 2 secant squared minus, and that'll actually be turned into a plus because it'll be a minus a negative, but it'll be 3 cosecant squared x. All right. So here's another one. We're trying to find the slope of the tangent line to the graph of this, right? So this time we're not even trying to find the equation of the tangent line, just the slope. So we're really just looking for f of a, right? F prime to a. So here's a, right? So we're trying to find, in this case, f prime at pi over 6. So first let's find f prime. So I'll let you fill that in. What is the slope, or what is the, what is the derivative of tangent? Good, if you got secant squared. Well done. All right, and now we want to actually input pi over 6 into this function, right? So let's use our trig chart here. All right, and go ahead and find what secant of pi over 6 is, right? And then we're going to put it in. So remember, secant squared is just like saying whatever secant is, we're going to square it, right? So go ahead and find secant of pi over 6, and then we'll put it in here. Good, if you got line secant up with pi over 6, you should have gotten 2 root 3 over 3. Good, and then we can just simplify that. So we're going to square everything, right? So we're going to square the 2, that becomes a 4. We're going to square the root 3, that becomes a 3. Then we're going to square the 3 on the bottom, that becomes a 9, right? So we end up with 12 over 9, and we can reduce that to 4 over 3. And so that's the slope of our tangent line. It's f primed at pi over 6, and it's also the slope of the tangent line at pi over 6, right?